Okay, welcome. Now we're going to be talking a little bit about how we can measure some aspects of fundamental frequency and just some general voice characteristics. And I guess we'll see what else we want to talk about here. Let's go with it. All right, so measuring fundamental frequency and intensity can be divided into three categories. So we can look at the levels of habitual use of the voice, the levels of maximum performance, as well as the degree of regularity. So measures of habitual use of the voice addresses the performance of the vocal system under routine use. Maximum performance tasks address the performance of the system under mechanical stress and the physiological limits of our system. And then finally, regularity assessment addresses how stable the voice production system is. Okay, so we tend to use a common range of fundamental frequencies. So the average fundamental frequency at which we speak is called our mean speaking fundamental frequency. That makes sense. And the range within which we typically speak is our mean speaking fundamental frequency range. And these are highly influenced by linguistic factors such as the speech content. A highly emotional topic might cause us to speak at a different fundamental frequency than a boring topic. Lack of familiarity or nerves might influence that fundamental frequency as well. So the mean speaking fundamental frequency and its range are assessed during sustained vowel phonation, reading, or spontaneous speaking tasks. Maximum performance tests, you provide information about the physiological capabilities of our voice production system. So the maximum frequency range of phonation represents the span from the lowest to the highest frequency at which the individual is physiologically capable. All right, so it can be elicited by having an individual phonate from lowest to highest pitch, at a self-selected loudness level. So maximum range of phonation frequency can also be elicited as part of a frequency intensity task called the voice range profile. Okay, so the balance of vocal fold tension and lung pressure contributes to both our fundamental frequency and intensity. So there's a close relationship between fundamental frequency and intensity. And this relationship can be graphically represented using a voice range profile or phonogram. Okay, so to create this representation, a tone is presented, beep, and a person is asked to produce a vowel at that selected pitch as softly and then as loudly as possible. And the intensity levels of the soft and loud trials are then recorded, as those phonated frequencies. The upper contour represents the maximum intensity at each frequency, and the lower contour represents the minimum intensity at each frequency. And so when you're looking at the overall area enclosed in those upper and lower contours, the wider the area, the more flexible your voice is, both in terms of intensity and pitch. The dynamic range is reduced at the upper and lower extremes and is usually widest around the mid-frequency range. So at the lowest frequencies, it's difficult to achieve increased intensity because the vocal folds need to vibrate at a slow rate. But there is overall resistance, to the airflow that must be, increased in order to, to withstand the increased lung pressure necessary for increased intensity. Okay. Similarly, at the highest frequency, there is a similar relationship between lung pressure and vocal fold tension. To achieve a high frequency phonation, those vocal folds must be quite intense, which increase their resistance to that airflow. So this would require high lung pressure to maintain that phonation. And such high levels of lung pressure, of course, would result in greater intensity. So finally, both the upper and lower contours tilt upward toward the higher frequencies. Men and women can phonate more softly in the middle frequencies than in those highest frequencies. They can also phonate more loudly at the higher frequencies than at the low and the mid frequency range. And again, this is due to that high lung pressure that's required for intensity, also requires that the vocal folds are able to withstand that greater pressure. And increased resistance is achieved with greater vocal fold stiffness. So, the stiffer they are, that's going to raise the fundamental frequency. So that's how this is all playing out. We can also look at an SZ ratio. And this is the maximum performance task that requires nothing more than a stopwatch, okay? So it's used to assess the integrity of the phonatory glottal closure. So it characterizes the relative pressures, the relative duration of the maximum phonation of S and Z. It's just a ratio between these two durations, so there is no unit of measurement. It's just a ratio. So we have your speaker produce S and Z, and so our S and Z are produced in the same place, the oral cavity, in the same manner, right? They're both alveolar fricatives. One's voiced, one's voiceless. S is voiceless, Z is voiced. So that means our glottis is open for S and vibrating for the Z. And so as a result, there should be increased laryngeal resistance during the production of Z as compared to S. And because the S has minimal resistance with that wide open glottis, there's going to be greater resistance during those closed vibrations of the Z. An individual should be able to sustain the S and Z for equal durations. Again, this would result in an S-Z ratio of 1. But if we have incomplete glottal closure during phonation, the glottal resistance will be lowered. And so this will allow greater escape of air, and the Z would be sustained for a shorter duration. And so this would result in a ratio greater than 1. So S, we can say, let's make it easy, we'll say S we can sustain for 4 seconds, but Z we can only sustain for 2. That leads to our S-Z ratio of 4 divided by 2 is 2 versus, S being sustained for 4 and Z being sustained for 4. 4 divided by 4 is 1. Okay. And what else do I have to say? All right, maximum phonation time measures the duration of a maximally sustained vowel. So again, let's use the name to help guide us along. So as with our S-Z ratio, this should be sensitive to impaired phonatory glottal closure. So we just ask our speaker to take a deep breath and sustain a vowel at a comfortable pitch and loudness for as long as possible. We time that duration with our stopwatch or with the second hand on the clock and see what it is. Men generally produce greater maximum phonation than women just due to their greater lung volume. But if you have an athlete who's got a good lung volume, especially a swimmer or a runner, they may have a surprisingly large lung volume as well. The measurement of the regularity of vocal fold vibration is an important characterization of the general health of our laryngeal system. While some variability in vibration is common, too much variability is going to result in an abnormal voice. Perturbation is the variability or irregularity in our system. So short-term fundamental frequency perturbation is called jitter. So this represents the non-volitional variability in the fundamental frequency as measured during a sustained vowel production. So it's that cycle-to-cycle variation in the duration, of the duration in the period. So this is basically when jitter is when your pitch essentially is changing and going that is jitter. Okay, that's when we don't see the same, we don't hear the same pitch across the board. So fundamental frequency perturbation provides us with information about the stability of laryngeal dynamics in terms of those vocal fold vibrations. The perturbation of the amplitude of the sound pressure wave can also tell us about laryngeal stability. Again, remember the amplitude of our acoustic waveform is indicating the amount of energy in our sound pressure wave. That's the intensity or the loudness of what's being said. So shimmer is that short-term variability in the amplitude of the acoustic waveform. So like jitter, shimmer is measured in a steady state portion of the vowel. So again, shimmer is essentially, if we can keep a stable intensity level, there we go, right? That is shimmer when we have this variability in what, in that sound pressure level, that intensity of what somebody is producing.